Okay, in this video I will be providing an argument to a math problem that was contained in the textbook. So the following problem is: the parallel sides of a trapezoid are contained by the lines y equals x plus 4 and y equals x minus 8. The question wanted us to write an equation of a line which contains the mid-segment of the trapezoid. So the first thing that we need to do is kind of talk about what the mid-segment of the trapezoid is. So I'm going to start by drawing a diagram. I'll use this one here. So let's kind of talk about the mid-segment of a trapezoid. So by definition, the mid-segment of a trapezoid is parallel to the two bases, which also are parallel, by definition also of a trapezoid. So that the mid-segment is parallel to the two bases. Another thing that it does is it splits these two sides of the leg into equal parts. Alright, so it's bisected here. Now, when we're trying to figure this part out, because we're going to write this in the Cartesian coordinate system, we want to kind of talk about the height of the trapezoid. Let's talk about that. What can we find out about the height here? Because the height of the trapezoid, if you think about it, these two legs are going to be represented by equations on the Cartesian coordinate system. The height, if we find some special information about it, it can help us pinpoint and not just guess, but demonstrate that the equation we provide for the mid-segment is actually correct. Because notice that it doesn't even tell you the size, right, of the bases of the trapezoid. It just tells you have two lines and it's contained. The bases are contained somewhere within the two lines, but we don't have any more information about them. So what we're going to do again is figure out what can we learn about the size of the height here. Okay, so let's go ahead and let's do this. So we're going to say that this little section here is called, we're going to let it be x. We're going to call it x. We're going to call this little section here t. You can pick any letters you want. I'm just using x and t. Okay. Now, real quick, oh, and by the way, I'm going to label this A, and then this one, since they're congruent by definition here of the mid-segment, then this one is also A, which means that the entire leg is 2 times A. Okay, well anyway, what I'm going to do now is, if you notice, what the height did here is it kind of, you can split this into a large triangle and a small triangle. And these are going to be right triangles because the height here is going to be perpendicular to the bases here. So we get a right angle on both of these. So then I'm going to draw a little triangle here, a little right triangle, and then a larger one. Okay. Now, let's go ahead and kind of label the sides here. So for the little one, we know that the hypotenuse is A, and we know that the leg here is x. For the big one, we know that the hypotenuse is 2 times A, so 2A. A plus A, right? And the height is going to be x plus t. Now, why is this important? Well, because if you notice that these two, right, these two are parallel, what happens is that our two little triangles here are going to be what kind of triangles? Well, watch. These two parallel lines are cut by a transversal. So I'm drawing the auxiliary lines here just so you can see how I'm doing this. It's two parallel lines of the transversal, right? So if you think about it, this transversal is cutting these two parallel lines. So what you end up with is congruent angles right here. So this one and this one. I'm sorry, this one. They're corresponding congruent angles. All of these are parallel. So, scratch that. This one and this one are congruent to each other because they're corresponding angles from the two parallel lines here that are cut by a transversal. Okay? So notice that these two angles are congruent and these two angles are congruent. So what does that tell us? Using similarity, we know that this and this are similar, so we have two similar triangles. So what does it mean to have two similar triangles? Well, it means that their sides are proportional, okay, by definition of similarity. So what I'm going to do is I'm going to set up an equation using proportions here. So we'll say a over 2a is equal to x over x plus t. Okay, because we have two similar right triangles, and so their sides are proportional. Now, what I'm going to do next is simplify this. So I'm going to put this little double arrow here. This a over 2a, it cancels out, and so we're left with 1/2. Right, the a cancels with the a here. X over x plus t. Okay, now I can multiply, cross multiply here, and look at what we get. We get x plus t is equal to 2x. So then what ends up happening here? Well, if we can actually solve this for t, and something interesting happens. Watch. Move x to both sides, so minus x, you get t is equal to x. Aha! That's actually quite interesting, because what's happening here is that this distance right here of this one, and this distance right here of that one, is also cut in half. Since we got that x is equal to t, then we know that, of course, the height is x plus x, so in this case h is equal to 2x. So we know that the height is cut in half here because you have an x here and then another x here. Okay, so why is that important? Because we can use a Cartesian coordinate system now to try and figure out where that line is going to be. So we can start by graphing our original lines. So here you have x plus 4. So I'm going to go ahead and draw it like this. Something like that. Here's 4. And then of course we have x minus 8. So this is negative 8. Okay. So why is this important? Because we want to find an equation of a line that's going to describe the mid-segment, right? It's going to contain the mid-segment in it. Now, intuitively, it seems very easy, and actually it's correct, the intuition here is correct, to just say, well, because remember, it doesn't specify anything about, other than the lines that contain the bases, it doesn't say anything about the lengths of the bases. So we don't have any information about that. But it seems intuitive that this line, the y-intercept, is going to be somewhere halfway between the two y-intercepts. So some people may have that intuition, and it's correct. That's actually the answer. It's going to be right in the middle. So what happens is the entire length here is 12, right? The distance from 4 to negative 8. And so negative 2 is that midpoint, right? It's right in the middle between here 0, 4 and then 0, negative 8. Okay, so now comes the interesting part. The interesting part is to demonstrate that this indeed does give us it describes the mid-segment. So this is how we're going to do this part. This is the most interesting part, actually. So I'm going to start by writing out my equations for the bases. Right? So for the top, we're going to say, I'll call it f of x1 is equal to x plus 4. And then I will write right here f of x, 3, is equal to x minus 8. And then, of course, I'm using this one to describe the line containing the mid-segment. So here the intuition is x minus 2, because we're saying, oh, it's going to be in the middle. So it seems easy enough, but I'm going to use mathematical relations and argumentation to show that this actually is the case, as opposed to just guessing. Again, because we don't know the lengths of the bases. We just know the lines that contain them. Okay. So I'm going to put a circle around this one here, because this is kind of like our tentative guess. Like we think that, oh, that's the equation that works. But now let's demonstrate that. Let's actually show that that's the one that works. Okay. So let's go ahead and select some arbitrary value. So you can pick any number you like for x. I'm gonna pluck it. I'm gonna put it right here. So we'll say here, we'll let x be, let's say 6. I'm just making up numbers here. It's arbitrary. You can select any one you want. There's nothing special about this one. So watch this. If I select 6, then what's the distance between, or actually what's the y value here? Because if I select 6, I want to know the point on the top part of the base, of the two bases, the top one, right, the upper one. So all I need to do is plug in 6 for my x value of the top equation, which I'm calling f of x1. So here I'm just going to put, I'll write it as y if you like. Y is equal to 6 plus 4. So we get 10. So I'm going to write the coordinates. I'll use a different color here. I'm going to write the coordinates in red. So here we have 6, comma, 10. All I did was I plugged in my x value and I got my y value. Okay, so that's for this one. Now the trick here, this is the trick. We want to check that this line does contain the midsegment. That's what we're trying to check. In order to do that, what we need to do is we need to find the height, right? The height, remember what I talked about here, the height? We need to find that height for our trapezoid over here. So I'm going to draw that in red. Okay? So we need to find that height. Now, how on earth do we do that? Well, what do we notice about the height of our trapezoid? It's perpendicular to those parallel lines. It's perpendicular to all three of them. Okay? So since it's perpendicular, we can use the equation containing this point to find a line that's perpendicular and crosses through that point. Okay? So when you're finding the equation of a perpendicular line, perpendicular to a given line, all you need to do is take the negative reciprocal of the slope for the original line. So here our original equation was x plus 4, the slope is 1, so that means we need to take the negative reciprocal to get the slope of the new line. So here I'm going to call this, let's call it h of x or something. This is going to represent the equation of the height. So here we know the slope automatically is equal to -1. So I'm going to write here negative x. We know that. But we don't know what the y-intercept is. Let's go ahead and write this in y-intercept form. So I'm going to say plus b. Okay. We can use these points because we want it to cross through that given, the point that we selected that was arbitrary. We want it to cross through there. Okay. So what we're going to do is use this point to actually find that perpendicular line, the equation to it. Let's do that. So what's going to happen here is we're just going to plug in those values. So we get 10 is equal to -6 plus b, and then we just solve for b. So 16 is equal to b. Simple enough. So that means that this equation for the height is going to be -x plus 16. So I'm going to put a little circle around that. Okay. Kind of scoot the paper here. Okay, so now we have this perpendicular line to this one here, to the first one we got. And of course, since it's parallel, then it's perpendicular to this as well. So now we can find the point that's on the base, the lower base. How do we do that? Well, all we need to do is, now we have an equation to describe this line. We have an equation for this line. So all we need to do is see where they intersect. So that system of equations, we're just going to set them equal to each other. So I'm going to write that step right here. So we're going to do -x plus 16 is equal to, and it's going to be, where's our equation? So we've got our height, and the other one is x minus 8. So this is just system of equations here. All I'm going to do is find the point of intersection so that I can know the point that lies on the bottom base. Okay. So now we can solve this part, and we get -2x is equal to, move the 16 to the other side. So then we get -24, and then we get x is equal to +12. Okay. So what does that tell us? I'm going to write this in red, actually. The point here is going to be x is 12, which we solved for, and then now we need to get the y value. So to get the y value, you're just going to plug in this x to either equation. So you can pick whichever one you want. I'll pick the second one. So we have h of x is equal to -12 plus 16. That gives us +4. which means this here is 4. Okay, so this, we have 2 points now on the upper base and on the lower base, right? 2 points that are they're solutions to those two equations, the top one and the bottom one. Now we need to check that the line x minus 2 actually does contain the midsegment. So on the top here, what we learned, what I set up here, was that this midsegment is going to cut the height into equal parts. So what that means, how this translates from, let's say, synthetic geometry into analytic geometry, is now we need to compute to see what is the midpoint between these 2 points, the halfway mark. Let's actually find that. So here, this is a separate formula. It's called the midpoint formula between 2 points. It's very simple. All you do is you add the two x values, so 6 plus 12. You divide by 2, and that gives you the x for the midpoint. And then you have 10 plus 4 divided by 2 gives you the y for the midpoint. So then this is going to be 18 over 2, so you get 9, comma, 14 over 2, so you get 7. So what this is saying is that the midpoint between these 2 points is 9, 7. Okay, now here's the punchline. Everything that I've been setting up is all for this one part, and I'm going to use purple for this. Now we want to check if this truly describes the midsegment. Then that line, this point must be on that line. If this point is not on the line, then our equation does not describe the midsegment. So now we have to check. The equation that I circled here for a midsegment is, I'll write it using y, the y letter here, y variable. So y equals x minus 2. We need to check that this point is on that line. So all you do is you plug in your x and your y. So I get 7 is equal to 9 minus 2. Ah, it's correct. 9 minus 2 is 7. 7 equals 7. See how cool that was? We selected an arbitrary point. We used this to find the point for the upper base and the point for the lower base. And then we used those 2 points to find the midpoint. And then we checked that the midpoint was indeed a solution to the equation for a line that we found for the midsegment. And that's our argument to demonstrate that x minus 2 is the equation for the line that contains the midsegment. All right.